Hello, once again, ladies and gentlemen, and welcome to our virtual classroom. I want to cover these questions from the review for tomorrow's exam, and so hopefully you find this helpful. Now, while I am going to be going through every single question, or I may or may not actually get to the answer, but I do want you to pay special attention to how I'm setting up the problem. That is what is really important for each one of these questions. For example, let's begin with number one. Question one. It says that Nicholas drove 0.75 kilometers to the park. How many meters is the question? How many meters did he drive? In other words, guys, I want to change this unit of kilometers into meters. We need to convert. And as we've seen with conversions, we always want to write down the units that we are using. In this case, I'm using kilometers and meters. Now, it doesn't really matter which is on top and which is on the bottom as long as you stay consistent. And so I won't be repeating that over and over again, but I will say it here, guys. Again, it doesn't really matter as long as you stay consistent. For example, now that I wrote down my units, I do need to ask myself, which one is bigger? Which one is bigger, a kilometer or a meter? Well, if you look at your conversion chart, you're going to find that 1 kilometer is 1,000 meters, or 1,000 meters is 1 kilometer. So obviously, a kilometer is way bigger. So that's the bigger one. So I'm going to put a big one. And we can see that it's 1,000 meters in 1 kilometer. Now that I did that, I can actually write down my equivalent ratio using this information. It says 0.75 kilometers. Since I put kilometers on the numerator, I'm going to put that number on the numerator as well. Had I put it on the denominator, then I would put it on the denominator. But no, kilometers, 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 and I want to know how many meters is 0.75 kilometers. At this point, ladies and gentlemen, you can always cross multiply and divide. Remember that that always works. However, in this particular problem, it's very easy to go from 1 to any number. For example, 1 times what will give me 0.75? Well, it's 1 times 0.75. And if I multiply the numerator by that, I have to do that to the denominator. And 1,000 times 0.75, if you work it out, that would give you 750. So there it is. There it is. Notice this pattern. This pattern, you're going to see it in a lot of these problems. So do be mindful of that. Let's go on to number two. Number two. Jennifer is riding her scooter at a constant rate. Okay, so that's a proportion. The graph shows the ratio of time and distance. Okay, which unit rate? Oh, write a unit rate to represent Jennifer's speed. Now, guys, remember that a unit means one, meaning that we want to know how far. How far? So we want to know the distance per minute. How far Jennifer will get in 1 minute. That's what unit means. How far is she going in 1 minute? And speed is always distance over time. Distance over time. So that's why the unit rate, I put distance on top and then time on the bottom. So we need to know the distance over time, the distance over 1 minute. All right, so having done that, let's look at this right here. First of all, ladies and gentlemen, if you remember when we talked about graphs, the graph of a proportional relationship will have two things. Number one, it's going to be a straight line. Notice that if I put the points together, they're all going in the exact straight line. And that line will cross the origin. Okay, again, it will always be a straight line. It crosses the origin. So that supports that this is a constant rate. It is a proportion. And we are comparing distance, which is miles, over time. In this case, we have minutes, miles per minute. And you might say, well, what is the fraction? What is the ratio? Well, it's right here, miles. So when miles is, for example, right here, when miles is 2, that same point, the minutes is 15. I can use that one. Or I can use this one. When the miles is 4, the distance is, the time is 30. So 4 miles in 30 minutes. Or over here, when it is 6, it's going to be 45, or 8, it's going to be 60. And I'm not going to go through this because, guys, you only need one of them. It doesn't matter. They're all equivalent. So I'm going to take the simplest one, the easiest one, so to speak. And remember, I want to find the unit rate. In other words, I don't want to know the miles for 15 minutes. I want to know how many miles are traveled in 1 minute. That is the unit rate. Okay, I'm trying to get to the number 1. And as we've done it, whenever we're trying to get to number 1, you always can divide a number by itself. So 15 divided by 15 will give you 1. 2 divided by 15 will give us our answer. So let's go ahead and work that out. 2 divided by 15. So 15 cannot go into 2, but it does go into 20 one time. 15 times 1 is 15. We have a remainder of 5. Let's keep going. 50 can go into 50 3 times, because 15 times 1 is 15, times 2 is 30, times 3 would be 45, so it goes 3 times. 45, and at this point, you're going to notice that it's going to go on forever, okay? It's going to go on forever. It's going to be 0.1333333. So, but we know that it's going to be about 0.13. I'm going to round to the nearest 100 miles per minute, and the closest answer to that, guys, you can see would be the letter D. So that would be the answer for this one. If you're confused as to what goes in the numerator and denominator, then you can just look at the answer choices. Notice they have miles per minute. That literally means miles per minute. So that's another way that you could see or verify if they want the numerator to be a particular unit and the denominator to be a particular unit. All right, this next one, guys, we see that we have Aliana can run 4 laps around the track in 8 minutes. Okay, that's Aliana. Julius can run 6 laps in 10 minutes, and Madeline can run 3 laps in 9 minutes. Who is the fastest runner? So we're talking about speed. Speed, guys, will always be distance over time. If you need to write that down, please do so. But speed, you know, we're seeing who's fastest, who's got the most speed, will always be distance over time, and it is going to be a unit rate. Meaning we want to know how much distance is traveled per 1 unit of time. So in this case, our distance is measured in laps and our time is measured in minutes. So we begin with Aliana, and Aliana does 4 laps in 8 minutes. Okay, so Aliana, so I'm going to do her in red here. She does laps per minute. That's her distance over time. And she does 4 laps in 8 minutes. So if I want to find her unit rate, I want to see how many laps she's going in 1 minute. So 8 divided by 8 is 1. 4 divided by 8 will be 0.5. So that's half a lap in 1 minute. That's for Aliana. Let's talk about Julius. Julius can run 6 laps in 10 minutes. So I'm going to do the same thing. I'm going to do laps per minute. So laps per minute. And he does 6 laps in 10 minutes. But again, I want to know how many laps are done in 1 minute. So divide by 10, divide by 10. If you divide 6 by 10, that's going to give you 0.6. Notice that he does a little bit more than Elena. Okay, so far Julius has the faster rate. He moves a little bit faster per minute than Elena. But we still have one more to see. Let us see Madeline. Madeline does 3 laps in 9 minutes. So for Madeline, we have her laps per minute. So she's doing 3 laps in 9 minutes. But again, we want to see how many laps she's doing in 1 minute. So divide by 9, divide by 9. And so 3 divided by 9. 9 cannot go into 3, but it does go into 33 times. 9 times 3 is 27. We have a remainder of 3. So it's going to go on forever. I can already tell. It's going to be 3, 3, 3, 3, 3, 3, 3, 3. So if I just compare the 10th place, guys, this has a 5, this has a 6, this has a 3. The fastest one seems to be Julius. So the answer would be B. Now that seems like a lot of work. Is there another way that I could have done this problem? Well, yes. We can just compare the ratios directly by cross multiplying. For example, if I take Elena, sorry, which is 4/8, and I compare that to Julius, which was 6/10. If I cross multiply them, remember this is Elena and this is Julius. So so I need to cross multiply. 8 times 6 is 48. 10 times 4 is 40. We can see that 48 is more than 40, so Julius has a faster rate. So you can just cross multiply the rates without simplifying them to the unit, and that will also tell you the faster rate. All right, next one. Number 4, Alejandro drove 297 miles. Okay, so that's a unit, 297 miles in 5.5 hours. So we have distance and time. Okay, so I can figure out a unit rate right there. At this rate, So distance over time. How many miles? We don't know the miles. Can he drive in 1 hour? So yes, they want to find the unit rate. Okay, so again, what are we comparing here? Well, we have miles and hours. So go ahead and write miles over hours. Miles per hour. 297 miles driven in 5.5 hours, sorry. But again, we want to find the miles for 1 hour. We want to find the unit rate. Okay, well, let's go ahead and solve this. Okay, so how can I get from 5.5 to 1? We'll divide by 5.5, which means that I need to divide 297 by 5.5 as well. So let me go ahead and work that out. So we have 297 divided into 5.5. Ladies and gentlemen, by now you should know that we do not like decimals on the outside. So I'm going to take the decimal and move it over once. And if I did that on the outside, I must take the decimal on the inside and move it over once as well. So now we have 2,970 divided by 55. Okay, 55 does not go into 2 or 29, but it does go into 297. Let me see what 5 would do. 55 times 5. 5 times 5 is 25. 5 times 5 is 25, 26, 27. That's 275. Yeah, that's close enough. So that's 275. So let's subtract. That's going to be a remainder of 2 and a remainder of 2. Let's bring down the 0. Okay. Right, because 5 times 5 is 25. 5 times 5 is 25, 26, 27, 275, 275, yes. Okay, let's continue. 55 goes into 220. Let's try 4 times. So 55 times 4. 4 goes into 5 20 times. 4 goes into 5 20. Plus 2 is 22. Oh, it goes exactly 4 times. So that's exactly 220. So ladies and gentlemen, that means that if she's traveling or he's traveling 297 miles in 5.5 hours, in 1 hour, he will have traveled 54 miles. So in your answer, guys, notice that it's only asking for the miles. So you would just type in 54. But again, notice the pattern. I started off, ladies and gentlemen, by writing down what am I comparing? Okay, miles per hour. What is the ratio that is given to us? 297 miles in 5.5 hours. And then I'm trying to get to 1 hour. And I just divided both by that. Could I have cross multiplied and divided? Yes, that always works. You can do 297 times 1, which is 297. And then you divide by the number that's left over. So that'd be 5.5. I still get the same answer. Okay, next one. And guys, if I am going too fast, I do recommend that you do rewind, or if you already know this problem, you can move on to the next one. Number 5, an athlete. Athlete weighs 68 kilograms. 68 kilograms. How much does it weigh in grams? Obviously, guys, I'm going from kilograms to grams. Okay. What's the next step? Well, which one is bigger, a kilogram or a gram? ¿Cuál es más grande? Which one is bigger? So I can see that 1 kilogram is bigger than a gram. So that's the bigger one. And we have 1,000 grams in 1 kilogram. You can get that from the chart. So if I have 68 kilograms, how many grams is that? It's almost like I'm telling a story as I do it. Well, how can I get from 1 to 68? Well, multiply by 68, right? And if I did that to the numerator, let us do this to the denominator as well. 1,000 times 68 is going to be 68 plus 3 zeros. So it's going to be 68,000. 68,000 grams in 68 kilograms. Yes, you could have also cross multiplied and then divided, but it's just 68 times 1,000 again, and then divide by 1, which would be 68,000. All right, next one. We're almost done. Bottle of soda contains 12 ounces, fluid ounces, cost $1.75. Ooh, cost per ounce is what it's asking. What is the cost per ounce? So we have cost per ounce. So let's go ahead and put cost, money, per ounce. That's exactly what it's talking about. So I'm going to put it in that same order. So the cost is $1.75 in 12 ounces. But we want to know the cost for 1 ounce. That's per ounce. Per always tells you what the 1 is. So per ounce is per 1 ounce. Well, ladies and gentlemen, how do we get to number 1? We'll divide 12 by 12. That means that I need to divide $1.75 by 12, and that'll give you my answer. All right, let's work it out. 175. And it does say to round to 2 decimal places because it is money. So money must have no more than 2 decimal places. So I'm going to round to the hundredths place. Let's divide that by 12. The decimal is already there. So I'm just going to move that straight up, guys. 12 cannot go into 1, but it does go into 17 one time. 17 minus 12 is 5. Bring down the 5. 12 goes into 55 4 times because 12 times 4 is 48. So when I subtract these two, 8 to 15 will be 7. Okay, let's keep going. Bring down to 0. And that's going to be 70. 12 times 5 is 60. And ladies and gentlemen, I'm going to stop right there, even though I could keep going, because remember, we're only rounding to 2 decimal places, to the hundredths place. So that means that I only need up to the 4. So I need to look at the next digit, which is the 5. And remember, 5 or more is add 1 more, something like that. 4 or less, let it rest. So since I have 5, I'm going to add 1 more. So that's going to make this into 15 hundredths or 15 cents. 15 cents per ounce. 15 cents per ounce. And you can actually do this when you go to the store. You can divide the price by the number of ounces in a drink, and you can calculate exactly how much you're paying for each one of those delicious ounces of Dr. Pepper, of course. All right, let's move on to the last one, ladies and gentlemen. And here we are taking a string measuring 8 3/4 feet, and that needs to be cut into sections. So it's equal sections measuring 5/8 feet. How many sections can be cut from the string? So we're obviously dividing this quantity, never mind that it's a mixed number. We're dividing that into that, right? If you need to write that down, you can. We're dividing 8 3/4. That's what we're going to do mathematically, divide it into 5/8. I haven't done any math yet. I'm just writing down what I'm going to do. At this point, ladies and gentlemen, I do need to remind you that we cannot multiply or divide with mixed numbers. Okay? We cannot multiply ever. Multiply anytime you're multiplying or dividing. It doesn't matter what the problem is. You cannot work it out if it's a mixed number. So I do need to take this mixed number and change it into an improper fraction. How? Well, ladies and gentlemen, do remember the Texas two-step. And what the Texas two-step tells us is to write Texas in between the whole number and the proper fraction. And then we always multiply and then add. So we basically do this pattern. It's like we're making a C. So 4 times 8 is 32. 32 plus 3 will give me 35. And then we keep the same denominator, 35/4. So guys, what I'm actually working out here is 35/4 divided into 5/8. Okay, well, how do I divide fractions? Ladies and gentlemen, you need to remember that we need to use keep, change, flip. We're going to keep the first fraction. We're going to change the division to multiplication and then flip the second fraction into its reciprocal. So whenever I do that, we're going to keep the 35/4. We're going to change the division to multiplication. Then we're going to flip the 5/8 into 8/5. All right, let's go ahead and work this out. Now, I'm just going to do it the simple way there. So 35 times 8 and then 4 times 5. Well, I know that 4 times 5 is 20. 35 times 8, so I need to work that out. 35 times 8. 8 times 5 is, sorry, 40. 8 times 3 is 24, plus 4 is 28, so that's 280. Already, guys, I can simplify this by taking out the 0, so that's just 28 divided by 2, and 28 divided by 2 is 14. That would be your answer. Now, is there an easier way to do this? Of course. In fact, right here, 8 and 4 both have a 4, so if I divide 4 by 4, that's 1. 8 divided by 4 is 2. And then over here, ladies and gentlemen, this is just another way to do it. You don't have to do it this way, but 35 and 5 both are divisible by 5. 5 divided by 5 is 1. 35 divided by 5 is 7. So now what are we left over? 7 times 2. Oh, that's 14. 1 times 1 is 1. So that's it. 14, get the same answer. Please remember, when you are multiplying or dividing, if you have a mixed number, use the Texas two-step, changing it to an improper fraction. Whenever you're dividing, guys, you must do KCF. You must do KCF, and then you just multiply by multiplying the numerator with numerator, denominator with denominator, but make sure that you do simplify. Ladies and gentlemen, I hope you found this review helpful. And with that in mind, I will see you next time.